Next, example 2.10.2. So we have 2-pound brick slide down a smooth roof with VA is equal to 5 feet per second. Determine the speed at B, the distance D from the wall to where the brick strike the ground, and its speed at C. So you have three. So you have VB, speed B, and then distance D, and then speed at C. Right. So you have two steps here. So step number 1, you need to draw the free body diagram to show the work done. So how many work done here you have? And then you can apply the principle of work energy to determine the speed at B and C. Okay. So you make a point A to B, point B to C, right? So you can have a AB 1 to 2, can like that, and then you can apply the kinematic relation to determine the distance at D here. Okay, next, so how many work done we have here? So for this block, so we have weight, right? We only have weight. So this weight is like this, not like this. Okay, and then what is the displacement? Vertical displacement. So from point A to point B, we have dy is equal to 15, and then from point A to point C, we have dy is equal to 45. So you can have the work done. A to B is W dy. So the mass is the weight. So the weight is 2. So why the weight is only 2 here? Because this problem is in the PFS system. So in PFS system, W is base unit. So you can just use this one. 2 times 15. And then the second work done at point A to C is equal to 2 times 45. Okay, next. So first, you can apply the VB. So here you can apply the from point A to point B. You substitute in this principle of work energy. So this is the what? T, right? TA. So this is a T, and then this is the work done. So this is the work done, and then this is the TB. Right, so TB, so this is the TA. Okay, so this one is M, right? So M is the derived unit. So W divided by D. Okay, so when you substitute everything here, then you can solve for the velocity. So VB is 31.48. Okay, and then similarly, we apply the work and energy principle in between A and C. So here we have the A and C. So you substitute the half mv square. So half mv square. So here is point A and here is point C. So this is point A, C. So here is the work done. Okay, work done subjected to the A to C. So we have 2 times 45 here. And then you solve this equation. Then you can get the VC is equal to 54.1 feet per second. Next, we want to calculate what is the D. What is D here? So here, you may apply the kinematic relation in X and Y direction. So here, you can apply this equation. So this equation, we want to determine the C. So XC here. So we'll substitute the X is become D here. And then this is the XB. So XB here is become 0 because we put the coordinate that exists at B here. So this is 0 plus with the VBX. So VBX we have calculated, and then don't forget to resolve the the XB, and then we need to calculate what is the TBC, the time. So how to calculate this time? Okay, so this is the equation first. We cannot solve yet the D until we substitute the TBC. So now the TBC can be solved by using this equation, the vertical motion. This one is horizontal, right? So this is the vertical. So the vertical YC is equal to YB plus VBY TBC minus 0.5 G TBC squared. So now you substitute everything here. So YC is become negative 30, YB is 0, and then this one the VB. So you resolve the VB, become like this, and then you substitute the G, so we can solve the TBC. So TBC is equal to 0.899. So you can substitute into the horizontal motion. So this is the horizontal motion. So we can solve D become 22.6 feet. Understand? Next example 10.3. So here we have block A. You may refer to this figure. Block A has a weight of 16 pounds and block B has a weight of 40 pounds. Okay, the coefficient of kinetic friction between the blocks are the incline is K is equal to 0.1. Neglect the mass of the cord and purely determine the speed of block A after block B move. So you need to determine the VA. What is the VA? After the block B move to fit up the plane starting from the rest. Alright. So in order to determine the VA, so VA you can get from the TA, because the TA is equation half MVA squared, right? So what is the information here you can have? So first you need to draw the free body diagram. No, first you need to define the kinematic relationship between the block. Second, you can draw the free body diagram, and the third one you can apply the principle of work and energy. So what is the kinematic relationship here? So here, so this is 2T because of from this cable, and this is the T. Okay, so the kinematic relationship here. Okay, so what is the kinematic relationship can be determined by defining position coordinate SA. So you can have that this is the, you can call it SA, and here is the SB. So what is the relationship between SA and SB? So since cable length is constant, so you can assume that length of the cable. So you can assume that 2 SA plus SB is equal to 1. So from here you can have the displacement. So the displacement 2 delta SA plus delta SB is equal to 0. So from here, so we can have here when delta SB is equal to negative 2, because it's given from the question, right? So the displacement SB is equal to negative 2 because of moving upward. And then, so we can have here that displacement SA is equal to 1. So, based on this, so we can assume that 2VA plus VB is equal to 0. So you can get what is the VB. So VB is equal to negative 2 VA. So this is the relationship from the kinematic. Okay, so here note that by definition of SA and SB, positive motion for each block is defined as the downward. Okay, next we draw the free body diagram for each of the block. So this is number 1. So number 1 for block A, number 2 is block B. So you show what is the force of the work done involved. So don't forget this is the X and this is the Y. Okay, so don't forget to resolve this one. So this is 60. Okay, so this is 30 degree. So this is the tension to T, and this is the weight. And because of the sliding given the rough surface, so we have the FK here. So FK is equal to mu K and A. So this is the normal acting perpendicular to the block. So here, so you can have here some force in the y direction for block A. So not that is the motion in the y direction. So in the y direction, you resolve all the forces into y direction. So y direction here we have NA minus WA cos 60. So you can have the NA is equal to WA cos 60. And then same for the block B. So we have the summation Fy is equal to 0 is equal to NB minus WB cos 30. So you can have that NB is equal to W cos 30. Right. So next, step 3, you can apply the principle of work and energy. Okay, you must remember that the block start from the rest. So you substitute what is the T1, what is the work done of the block, and what is the T2 here. Okay, so you substitute what is the T. Okay, this is the T1. TA. Okay, and then this is the what? The work done, right? So this is the work done from block A. Okay, work done from block A. And then this is the displacement. And then here, this is the work done from the block B, and this is the displacement. Okay, so here you substitute the kinematic relation that we have established before. Okay, you substitute this one into the equation. Alright, so you can solve it. So we understood that VA1 VA2 is 0, so that's why we have 0 here. And then you substitute the displacement. This one is 1, right? This is the displacement 1. And then you substitute the NA and then NB into the equation. So you can solve it. Then we can get the velocity is equal to 0.771 feet per second. So not that the work be done due to the cable tension force and each block channel cancel each other. Okay. Okay, that's all for today. So hope you can achieve the outcome of the lecture, which is number 1, the particle motion caused by the work of force has been described. And then you should be able to draw the free body diagram to show all the work done on the particle motion. And then number 3, you should be able to apply the principle of work energy to solve the force, velocity and displacement. Okay, don't forget to do your tutorial and the pop quiz. Okay, that's all. Bye.